Hello everyone. In this lecture, we will study bilateral Laplace transform and its inversion. First, we will study the definition of bilateral Laplace transform. Why to define the bilateral Laplace transform? A complex frequency domain analysis for describing systems. However, the unilateral Laplace transform can only describe the causal systems. To describe the causal and the non-causal systems in S-domain, it's necessary to define the bilateral Laplace transform. This is the definition of bilateral Laplace transform. The inversion of bilateral Laplace form is defined in this equation. The condition for convergence of the bilateral Laplace transform is the absolute integrability of this signal. The region of sigma for which the bilateral Laplace transform converges is termed the region of convergence. First, we'll discuss the finite duration signals. Determine the bilateral Laplace transform for the signal and its ROC. According to the definition, we can get its bilateral Laplace transform. In the procedure of computing the bilateral Laplace transform, there is no restriction to the S. So, the ROC is entire S-plane. We can depict it in this picture. The second is right-sided signals. Determine the bilateral Laplace transform for this signal. According to the definition of bilateral Laplace transform, we can get the result. In the procedure, we need the real part of S should be greater than -2. The ROC can be expressed in the picture. This is the S-plane. Let's discuss the left-sided signals. Determine the bilateral Laplace transform for this left-sided signal. According to the definition, we can get the Laplace transform is this expression. In the procedure, we need the real part of S should less than -1. The ROC can be depicted in this picture. Its real part of S should be less than some number. For the right-sided signals, the region of convergence should be greater than some number. The number is the real part of the pool. For the right-sided signals, its region of convergence should be less than some number. The number is the real part of the pool. Without the region of convergence, the x of S does not correspond to x of t uniquely. these two different signals, they have the same function in S domain, but the region of convergence are different. So X of S plus ROC corresponds to signal in time domain uniquely. We will discuss the two-sided signals. Determine the bilateral Laplace transform of this signal, and its ROC. According to the definition of bilateral Laplace transform, we can get the result for this signal. In the procedure, we need to satisfy these two conditions. This is the ROC. It can be depicted in this picture. Does any signal x of t correspond to x of s plus ROC? For example, here is a two-sided signal. This signal doesn't correspond to any x of s because these conditions cannot be satisfied. Now we will study the properties of bilateral Laplace transform. This is similar to the unilateral Laplace transform. So we will briefly introduce the properties. This is a time shift property. This is a differentiation property. This is an integration property. This is a list for the properties of bilateral Laplace transform. Now we are studying the inversion of bilateral Laplace transform. Direct inversion of the bilateral Laplace transform is also complicated. We can determine it by partial fraction expansion. For our right-sided signals, we have these transform pairs. For the left-sided signals, we have these transform pairs. We will use these transform pairs to find the inverse bilateral Laplace transform. Here is example. X of s associated with different regions of convergence. It differs to different signals. There are two poles. One is -2, another is -3. So we can get 3 different regions. The first one is the real part of S is greater than -2. The second one is this region. The third one is this region. We should know, in the region of convergence, it doesn't include the poles. So there are 2 poles should there exist 3 different regions of convergence. For this region, the signal should be right-sided signal. because the real part of S is greater than a real number. So the signal x of t should be a right-sided signal. For this region, the signal should be two-sided signal. For this area, the signal should be left-right signal. For this region, it's corresponding to the signal should be right-sided signal. For this region, the signal should be left-sided signal. So according to the region, we can find the signal type. Here is a quiz. According to the x of S and its region of convergence, and find its x of t. Because its region is the real part of S is greater than -3 and less than -2. So the signal x of t should be two-sided signal. Because this real part of S is less than -2, so this signal should be left signal. Because the real part of S is greater than -3, so this signal should be right-sided signal. So according to the analysis, we can find the right answer. This is the region of convergence. In this lecture, we have studied bilateral Laplace transform, and we discussed the properties and the inversion of bilateral Laplace transform. That's all for today. See you later.